Hello, and welcome back to another Max MSP tutorial. Today's video is about the Belousov-Zhabotinsky reaction and how to simulate it in Max MSP. So I got the info for this from this scipython.com blog. I'll link it in the video description. It's for, simulating it in Python, but we can do the same thing in Max. So this is what it looks like. And I guess I will go ahead and kind of start from scratch for you guys so you can see exactly how this is made. So I'm going to close this. Yeah, sure, save it. And we'll start a new patcher. So the first thing we need is our jit.world. This is the renderer and the thing that handles all of the video frame rate stuff. We want full screen anti-aliasing on, and then we want our erase color to be black. So there's our little window. Let's go ahead and make a few message boxes for floating and full screen. And then to trigger the full screen, I'm going to use the key, which is the keyboard output. And if we select 27, which is the escape key, we will be able to full screen. And we need a toggle to just turn it on. There we go. And we want to be able to see our frame rate. Comes out of that middle one. And we also want to send those bangs for the frame rate to, well, I just call it metro usually, or bangs, or render, something. And so yeah, that's just kind of boilerplate stuff you need to set up. And now we need some noise. I'm going to use the noise to populate our matrices with, numbers, and then the reaction will happen based on those numbers. We'll go 250 by 250 for our matrices. Yep. We want 3 planes, 1 for each color. Dimension 25 by 25. And then what we want float. So that's going to go into our matrix. It's going to bang our matrix. We also need something to display this matrix. So we're going to use a jit.gl.videoplane. So now we've got noise, but we're just getting one color of noise. Why are we just getting one color of noise? I've forgotten to do something. Let me open this back up. Even I forget things. Oh, it's float 32. That's what it is. And this probably also has to be float 32. There we go. Well, we've only got horizontal lines now. Does noise not have dim dimension? 3, float 32. Oh, okay. There we go. There's our noise. All right. Now get out of here. So we've got our matrix. We've got our video plane that shows our matrix. I'm going to go ahead and make, 32 is the space bar. So whenever we hit the space bar, we'll get new noise. So now for the fun stuff, .gen, and we open it up. So first thing we have to do is average all the cells, neighboring cells together. So we're going to need to do a lot of adding, and we're going to need some norm. We're going to need, oh God, what are we going to need? Honestly, let me open the other one back up. I knew I was going to be doing this a lot. It's been a while since I've really messed with this patch. Okay, so we need the normalized coordinates for each one of these. So we're going to need a lot of norm objects. We're going to need nearest. That's the object I was thinking. We are going to need a lot of the nearest object. And that is what's going to be added together. So this is just saying you're taking each cell and adding it with something. And we're going to need to divide them all by 9 at the end. So now to get the next cell, so this is the center cell, we have to add something to this norm. And what I did in this one, I just added 0.004 because that's 1 divided by 250, which is our dimension. But you really should make it easier for you to make, it would be annoying if you wanted to change the size and you'd have to go back and edit all this. So we're going to do it the smart way. We're going to make a parameter called dimension. And then we're going to divide, we're going to make it 250 first, obviously. And then we're going to divide it by 1, or 1 divide by that. Can I do the reverse division? Yes, I can. Okay, so this means 1 is being divided by the input. If you just did divide, if you didn't include the exclamation point, you just divide by 1, which doesn't do anything. So there we go, divide by 1, and then we're going to add that. Oh, we have to swizz out the dimensions, don't we? Yes. Oh, okay, we can just, I see. So we do have to swizz out the dimensions when we want to add to one and subtract from the other. Oh, this is complicated. It's kind of annoying to do this actually in Gen. So actually I might have to swizz this out because I can't just do like 0 for 1. Yeah, I guess we're just gonna have to swizz. And so we want to add this to the X, but not the Y, and then we want to combine them again. And then add that. So we're gonna have to do that for each of the remaining cells. So that one just added 1 to X, so we need one that just adds 1 to Y. So let me condense this a little bit. make it kind of easier to see. And then go ahead. Didn't mean to do that. So we're just going to need all this again, basically. Just copy it over. But instead of adding it to the X, we want to add it to the Y. And I'm going to have to move this one. So now we've got two different cells. And we're going to want to add these. So I hope this makes sense what I'm doing. I have to average out each cell with the ones surrounding it, and the way to get that is by doing this. Looks very complicated, I know. So in another one, we're going to have to add this to both. So go ahead and copy that, add it to the X as well. Ugh, it's going to get messy. Nope. And then we can honestly go ahead and copy all of these now. This is a little bit more of a cumbersome way to do it, but it makes it easier in the long run if you want to change your dimensions. Move this all over. So now we want to do the same thing, but all we want to do is change this add to subtract, add to subtract, add to subtract, add to subtract. So that's 1, 2, 3, 4, 5, 6, 7 cells, and now we just need the two where we're going to be adding one and subtracting the other. So I just need to copy this a couple more times. In one of them, I just want to change this to a plus, and then in the other one, I want to change the opposite one to a plus. So there you go. That's just averaging all the cells together. I really want to clean this up, but I'm not sure if it's going to be worth it for you to sit here and watch me make this look better. God. Yeah, I'm just going to kind of have it go off the screen there so we have room. So now we want to do the actual math. This was just kind of averaging all the cells together beforehand. So if we look at our formulas, so the next frame equals the previous frame plus a multiplication kind of thing. So we'll go one step at a time. Start with A. So first we have to swizz X, Y, and Z for our three matrices. I need to add Okay, so let's look at that formula again. So A plus A times, okay. So we need our parameters now. Param A, param B, param C. And those will all start out as 1. And then, so we're going to have to multiply those. So the first one was multiply E, A, and C, or alpha and gamma, but I'm using A and C. This is going to be confusing because the labels are kind of switched. The Swizz X, Y, and Z are the A, B, C, and then the params A, B, and C are the alpha, beta, gamma. So I already forgot what I was doing. So B times A, or alpha, minus, was it C times gamma? Yes, okay. C times gamma, or C in this instance. And so then we have to multiply A by this. And there we go. That's the first line of the equation. And then, oh no, that's not what I wanted. For the next line, it's going to be something similar. We're going to need to add. I'll just go ahead and do it for both of these. And then we'll combine them back. Just doing this so I don't have to do it later. Oh, and then we want to clip between 1 and 0 so that values don't go crazy. So the rest of the formula, I'm sure I'm going to need some multiply by b's because we haven't done that yet. And then one more A and one more C. And we're going to need some minus things in here. Okay, now let's see what's going on. So the next one is C times beta. So C times beta subtracted by A times alpha. And then we're going to need another multiplication. And that multiplies just by itself before adding to itself. And then the last one is gamma times A. So C times A minus beta times B. And then multiplied by itself before adding it to itself. So now, theoretically, this should work. Where's our screen? Oh, and of course, I haven't actually done anything. Oh, and then we need to feed this back into our matrix, of course. So I got to name this matrix and then just make another one. Oh, and I also have to send the bangs. That's why I said send the bangs. And why is it not working? Pause. So this jit.gen that I have is just doing offset stuff. We don't have to worry about that. So metro into the matrix. That should work. Where's our stuff? Why are you not working? What did I do wrong? So it looks the same, other than the things we added here. What happened? Oh, hello, there we go. Why did that work? What? Excuse me? I'm not sure what's going on here, actually. What the hell? I clearly don't know how this program works. So it works somehow. I'm gonna save. I'm gonna close it. I'm gonna close this other one. Gen patcher not compiled. Maybe that was our issue. What else is back here? Get out of here. Let's try this again. Okay, so now it doesn't work because it shouldn't work. And if I do this, maybe it works. Oh, and maybe now it works? No. Do we just do this? Okay, that makes sense. What, gen patcher not compiled. Why is the gen patcher not compiled? Oh, I think I'm not allowed to use dim as a parameter, maybe. Shit. Cool. So, what do we change that to? Oh, maybe it's because I have a bunch of them. And I only really need one. That's probably what it is. I just have to... Okay, make sure this goes everywhere. Oops. Get that one out of there. Get that one out of there. Okay. So wherever I see that exclamation point divide, I gotta plug this in there. Is that all of them? Now maybe? Or maybe I do have to call this something else. There we go. I just had to call it something else. All right. Well, hopefully that was educational and helpful. Sorry for the hang-ups, but hopefully you can kind of see how you can problem solve in Max. Hope this was helpful and you found it useful. And come back for the next tutorial.